So you have an idea, and one thing they don't talk enough about in entrepreneurship is feasibility. Meaning, people say you have an idea, go make a prototype. No. You have 3 pillars you have to deal with. You need to look at all 3 of them and say, yes, maybe you haven't done it yet, but you don't see any reason why you can't do everything. And that's when something becomes feasible. It's feasible to go do it. So why don't we just start diving into a business? And why don't we do it? Fear. When you're making all these investments and there's so much uncertainty, people get afraid of making a bet on you. What is fear? Fear comes from risk. And as we know, risk is the probability times the severity of what will happen. So what kinds of risk are there? Well, there's technology risk. Is it going to work? Financial risk. Can I turn a profit? What about reliability? That's something people don't talk enough about. We were making an instrument for the military, and my boss was all happy because we had a 90% start rate. And I said, Dan, 90% is horrible. You're in the military and this thing 1 time out of 10 won't work? I said, no, we have to bring the reliability up to the level of being a dial tone. That's how good it needed to be. Liability, if something goes wrong, who's going to pay? And companies care about that sort of thing. Programmatic risk has to do with your execution, your project management, your schedule, how many resources do you need, cost, those types of things. And finally, market risk. Is anybody going to buy it? We want to show that there's acceptable risk in doing this. You want to show your idea is worth taking a chance on. So to get through feasibility, you need to know what the question is. What's my winning strategy? And what solutions do I have for this? Now, you don't necessarily have to prove the solutions, but you have to show a story where people can follow and say, okay, that makes sense. What are my first questions? What do I need to know? Now, can you describe your idea within 60 seconds? Because if you really understand it, you should be able to articulate it like that. And if you can't, or you fumble through it, or it drags on too long, then you don't really understand your idea. What's its value? And how are you going to execute through the 3 pillars? Richard Feynman, arguably America's greatest physicist, he worked on the nuclear bomb. He once said, if you can't explain it simply, you don't understand it well enough. So you really need to know it forwards and backwards. Nobody on the planet should know more about your idea than you. And Feynman said this by saying that you can explain Laplace transforms to a 5-year-old. But do you understand it well enough to do that? What I do is exceptional, can make a sustainable profit, and is difficult to copy. Those are the first questions you have to answer. Then in terms of the pillars, how are you going to pull this off to actually build a company? And before we talked about the gates, and I'm not going to go through it again, but the gates are logical, and these are the basic questions that companies have. Can you answer those questions? Now, anytime you have something that has uncertainty in it, it's a game. And your first choice in a game is, are you in or are you out? One thing they don't emphasize in entrepreneurship is you are allowed to say no. You are allowed to bail. They make it sound like, oh no, there's no situation you should bail on. Yeah, there are. If you only have a 1 in a million chance of your company being successful, you should fold up shop. Only 1 in 10 technologies are market feasible, and yet Dr. Cho is 4 for 4. Does this mean he's a genius? No. Actually, if you talk to people from MIT, the words village idiot comes in. But here's why I was successful. I didn't pick losers. If something wasn't feasible, I didn't chase after it. And some of those dimensions in feasibility are things like time. If something was going to take 5 years or more, forget it. It's too long. I want something I can execute within 3 years. Why? Because if something goes wrong, then I have some slack. When you're 5 years out, there's not a lot of slack out there. So you have to think about all the risk dimensions and your pillars. So who wins? Somebody who sees this much of the problem? Someone who sees this much of the problem? Or somebody who sees this much of the problem? Or maybe the person who sees this much wins. And I've always tried to be the person on the right who could see the whole picture. And this is part of the problem in entrepreneurship, and that's that people have biases towards marketing, towards strategy, making money, or the product. However, you need all three to work, or you can't build a company. And the way to think about it is the probability of putting all these things off are in serial. So all you need is one bad probability and the whole thing just doesn't work. You have to decide, am I in or am I out? Now, there are basically 4 solutions to risk. You can mitigate it, which a lot of people talk about. You can avoid it, take a different path. I've done that before. This is going to be too hard. Let's find a different way to go do it. Transfer it, give it to somebody else, or just accept the risk. And no one may know what the solution is, so you just take it on. But that's the source of your answers. In order to find an answer, they exist in 3 states. Maybe the answer already exists. Maybe the pieces exist, meaning the whole thing put together doesn't exist, but the components do exist, or the answer doesn't exist. And this is where you need to go do experiments and prove. Why should you not go after something? Well, maybe it's got very little added value. It requires too many resources, or it's too hard, or maybe it's insignificant. So in terms of eliminating it, transfer it, avoid it, or solve it, those are what your options are. It's about severity. How do I reduce it? Reduce it again. Mitigate it, transfer it, avoid it, or accept it. These are the sources to your answers. Now, you can't do everything, but can you come up with a credible story that people believe that, yes, you can get there from here? But eventually you're going to need resources. Investors realize you're not going to have all the answers to begin with, but what they want to know is that you understand how to go out and find those answers. Startups can be in feasibility for a long time. Biomedical, you might be in feasibility for 10 to 20 years, and then you got to go through the FDA. University research can go on for 5 to 15 years. Where university research fails is in terms of reliability of manufacturing and cost. Because researchers aren't concerned about that. But every time somebody talks about this great piece of technology that comes from a university, I just kind of roll my eyes. Because the question is, will it meet these 3 things? And science could take up to 30 years. And you're talking about theory going into practice. Here's a scorecard. An idea of how you can weigh these risks out and thinking about what your factors are. And the scorecard you're going to see again, because this is how you also evaluate companies. At the end of your feasibility, now you're ready to go after your alpha or your prototype. So in terms of prototyping, we know we've got basically 4 kinds of engineering. So depending on what category I'm in, how do I prototype it? And so we're going to talk about technology, how to solve problems, and how to find a way to come up with these prototypes. If you can visualize it, you can do it. Today we see how. So we know about feasibility. Prototype demonstrates key functions, but it doesn't have to be to specification. Your alpha is functional, but doesn't meet all the specifications or exists for market testing. Your beta passes validation. It actually shows all the features. but it's in the process of meeting verification, which means you could do it more than once. And your gamma is that it passes verification and is now being tested for manufacturing. In terms of a prototype, engineers tend to be very wasteful, and that's that they don't want to take anybody else's way of doing things. They got to do it themselves. And that's a problem with research commercialization. It takes a lot longer than it should. List out your value proposition and figure out which values are most important to go ahead and demonstrate. And during the alpha phase, you start telling everybody what your problems are. Be careful not to hang yourself. It's okay to talk about problems and be honest, but always have an answer to that problem. You have to also manage your expectations. A lot of people in startups get so excited about what they're doing that they raise everybody's expectations not to be reasonable. Which is superior? Find what people want and make it, or connect to a value and make something and figure out who's going to love it. And this gets into minimal lovable product. Instead of making something minimal MVP, you're trying to make something that people are going to love over time. The goal of your prototype is to demonstrate enough value so you can move on to the next stage of development. After fundraising, you can hire experts to clean certain things up. So some examples are the microgyroscope. The microgyroscope initially, this is a 2 millimeter by 2 millimeter size chip. This is what it is. It had a covering to protect these small mechanical structures. And it also had some channels in it. And when you look at these channels, how small is this? Well, to get a feel for it, here's a window over here, and this is Abe Lincoln's nose on a penny. The prototype was the size of a toaster, and people were saying, I can't sell this. Are you crazy? And we just said, take it to them. So they took it to GM. They took it out for a test drive. They're doing like donuts and stuff like that. Gyroscope worked perfectly. And so they say, okay, what's the deal with this thing being the size of a toaster? We popped the toaster open and showed, look, the pack for the chip is tiny, tiny. All this room is for boards, for the electronics. However, we're going to take all these boards and shrink it into an ASIC, an application-specific IC. And a lot of people were doing that at that time. And so, okay, we can buy that story of how you're going to make this small. Instagram, the photo worked, but not much else. And Dyson, he actually came up with 4,000 prototypes. And it wasn't until he went to Japan did he finally start getting sales. Because one thing about the Japanese is they love design. And so Dyson is a very unique design. But essentially, he was funded by his wife who was working in debt. Now, when you look at this cochlear implant, and this helps deaf people to hear, this was the prototype. The problem is you look at this, and this thing is so humongous, it has so many pieces. You can't come up with a simple story of how you're going to get there. The batteries alone are way too big. So how do you get from this to something like this? And so this type of research is somewhat questionable. In terms of lean development, the more physical you get, the less lean works. And part of it is that in terms of experimentation, it's not like software where you can do things very quickly. And you have to be careful about your quality because if it's sloppy, you have to do it all over again. Musk brags about how he uses Agile in his rockets. If he was so fast, why did it take him 15 years to launch the first rocket? That's oversold what he talks about. But anyway, depending on whether it's software physical, are you selling to a customer or you're selling to a business? People have different standards. And the forgiveness for software is a lot harder than hardware. Because hardware, there's a lot more intimacy because people are holding in their hands and looking at it. Now, one problem startups get is you get stuck on a problem and you start spinning in circles. And unless you can break that, it's all over for your company. they get lost in the woods. If you get lost in the woods, stop. Take a step back. And instead of looking at the woods, look at the forest. And see where you actually are in the whole big scheme of things. You need to learn how to focus in and out. So prototypes, what can we do? We can do it ourselves. We can develop resources to get other people to do it. We could be well capitalized, pay for someone else to do it. We can bootstrap, and bootstrapping is using the resources you currently have and trying to leverage them in a unique way. Now, I talked about Apollo 11 that had a 3 megahertz processor and 16 kilobit RAM. You've got 1,000 times more computing power. But what did they have? Will. Will counts. It's more than just about technology. It's your will to exercise it and to use it. An example is fire hose rates, different depending on which nozzle you use. And so they used to use a piece of paper to do paper equations to figure out what nozzle they should use. And then what happens is a couple of firefighters wrote an app. And the thing is, they weren't coders. They taught themselves. And why? Because they have will. This is a do-it-yourself world. This is the age of content, marketing, and networks, meaning they're willing to give you information how to do it. And due to internet and globalization, information's not a barrier. It's out there. Now, in this break, there's a couple of videos. And these videos come from First Man. And you really see what those early astronauts went through to be successful. It's fascinating to look at. And those stories were true. Armstrong almost ran out of fuel trying to land on the moon. Do it yourself. Components. I have an idea. I need a place to work. And I need tools. So where can I get that stuff? Well, in terms of where to work, you could do it in your home garage, which is what a lot of people do. Or there's a lot of cheap kind of places where you don't have to pay a lot. And so there's a lot of places like WeWork that have share space, which charge you a couple $100 a month. You get a very small office or a desk or something, but the thing is you can use the conference room and stuff like that. And not only that, but you get a mailing address. Now, in terms of labs that have expensive tools like CNCs and all, you can't afford that. However, ASU and other universities rent space out their labs. They want industry to have access to these things. You can get vendors to do test runs for you. Although those relationships can get hard because unless you buy something, yeah, they're on you. Software, lots of different training opportunities for you to learn how to code, including classes here at ASU. How does physical technology works? This is why I could do chemical engineering, mechanical engineering, and electrical engineering. They're the same dog with different fleas. First, you have a boundary condition. There's some physics equation that defines how these things operate. And normally they're differential equations. So in terms of design, you start setting limits on these variables. Materials, basically you start plugging in as the constants. And then you have a perturbation. Basically something's changing, so how is it going to respond? That's it for physical technology. And as you could see, once you set it up, then it's about just going through a whole bunch of math. But now you have computers that'll do this stuff for you. So if you're afraid of the math, don't be afraid of it. Now, mechanical engineering is about design, materials, fabrication, assembly, and test. And so do I really need technical people or can I just outsource? And so there have been doctors. Airbnb didn't bring on a software engineer for a year. And Michael Dell was a pre-med major. What it comes down to is what is your will to find the answers? These are the sources that you can get to make up for the mechanical functions. And here are places where you can find them. And things like materials, you can actually buy them on Amazon. I've bought Teflon on Amazon. I've bought aluminum on Amazon, although Online Metals is a better place to go. And in terms of tools and assembly and all, you can buy your own tools. And so mechanically, you can do quite a bit. Not only that, the design software, a lot of it is available to you as ASU students. In terms of electrical, it's about computing, communications, circuits, ICs and sensors, and coding. Circuit designs, boards, you have to populate the boards, coding it, testing it, and publications tell you how to do this stuff. The IEEE is the largest technical association in the world, and they have 39 different societies with all kinds of papers. Vendors, remember this is a do-it-yourself world. People love to post their designs. Why should you design a motor controller? Somebody else has already done it, and they actually have design tools for you. Why? They're encouraging you to do this stuff so you'll buy parts from them. And this is what it looks like for DigiKey. And not only that, but when you're trying to estimate costs, what they can do is actually give you a price break according to what the volume is. And so for this one, they don't have it because they don't sell enough. But the data sheets tell you exactly how things are put together. So as you can see, this is a 3-axis gyroscope, and it tells you what you have to plug in to get this to work. That's it. Motor controller. Zigbee is actually a wireless protocol. So you can actually make your own wireless systems. And these designs are all there for you. Now, in terms of code, I'm not a C coder at all. Well, there's something called graphical programming. And this is called LabVIEW, and it's very easy to use. It only takes you a couple of hours to get started. So what do you do in LabVIEW? It's called graphical programming, meaning, okay, supposing I want my motor to shut off if the power threshold gets too high or the temperature gets too high. So if you look at this, you have a constant, and so and these are sensor ports, and if it gets too high, if one or the other happens, then the motor stops. That's it. Just connecting those things and making wires. Okay, it's not the slickest looking thing and all, but the point is you're just trying to show functionality. There are modular instruments like this. Some of them are at Tech Shop or ACIC, whatever they call it now. In terms of electrical prototyping, you can make your own boards. And how hard is it to make a board? Well, it's just soldering. Take a little solder, take an iron, put them together. That's it. Chemistry. You can buy materials online. The problem is that you need an industrial place where you could deliver it to, and that's where HiveNet ShareSpace help. To make benches, these things are pretty expensive, anywhere from $5,000 to $10,000. You can buy it used. There's a lot of used equipment out there. Or you can make your own. What is this? It's just a box with a window and basically a stone counterpart. And you can hook this up to a blower, so basically the air always blows in and goes out. And how can you tell you have enough velocity? Well, there's something called the paper towel test, and that's if you take a paper towel, tape it to this. If it blows in, then you have enough airflow. In terms of personal equipment, you can buy your own. I have all my own. Actually, when COVID broke out, I had gloves, I had masks, I had everything. And I just said, I told you there would be a problem someday. But anyway, in terms of waste, there are vendors that come pick it up for you. On the other hand, if you have a small enough quantity, and especially if it's an organic volatile, you could just let it evaporate into the air and nobody will say anything. In terms of computing, a lot of you are probably familiar with Raspberry Pi. Think about it. You can get the computing power equivalent to a phone for about $10 used and 90% $90 new. Now, here's an example of somebody who had will. A friend of mine, and I was actually the godfather to her daughter, and she was worried about SIDS, sudden infant death syndrome, and it was attributed to babies rolling over in the middle of the night. And so I said, it'd be easy enough to make a sensor. And she said, why don't you do that? And I said, I don't have time. And then I heard, you bastard, this is your goddaughter and everything. I said, it's not hard. I'll show you how to do it. And so I told her what to read. She bought her own pressure sensors. She learned how to solder. She followed the application notes. And then she got fancy on me. She put a beeping sound and a light going off. She built her own. And she was a Harvard history major. And she had a lot of fun. And she really enjoyed it. And so now you could buy these things off the shelf. But at the time it was custom. These are the kind of people you can look for. One thing about ASU, they have a great classified section. If you want to post an ad looking for somebody, go ahead. It doesn't cost you anything. I used to love hiring ASU students. In terms of intellectual property, remember, if they can reverse engineer or patent it, if they can't, trade secret. In terms of product development choices, again, don't pick losers. If it's not going to work, it's not going to work. And picking technologies is like picking investments. There are a lot of different dimensions you have to consider. And so maturity, cost, project management, execution. Are you just playing at this? Is this just a game, or are you really serious? Engineers don't appreciate the bottom line, and that's why so much of the emphasis shifted over towards marketing. But real entrepreneurship is about executing. Remember, if a decision involved, it's a game. And your first choice in every game is, are you in or are you out? I've always said that if there's nothing that tells me that it'll fail, then my odds are 50-50. Meaning there's uncertainty. There's things that you don't know, but those things you don't think are going to be so bad that it'll stop you. There's no showstoppers. So every time I pick something, it's like, okay, I got a 50-50 chance. Again, we talked about Star Trek in The Road Warrior. And so we have plentiful resources for prototyping. We have plentiful resources for prototyping. But do you have the will? You have intelligence. Believe it or not, if you're not an engineer, you can be an engineer. You just have to have a willingness to learn. There's no I can't in entrepreneurship. If you say I can't, it's time to fill up the tent. One time, a group came to me who worked for me, and I said, Steve, we can't solve this. And I looked at him, and I said, so you're really telling me you can't solve this? No, we can't. And then I got up and started putting papers in my book bag, zipping it up, turning off the light at my desk. They said, what are you doing? And I said, I'm going home. You can't go home. I said, yes, I can. You told me we can't do this. If we can't do this, then it's time to go home. And they said, wait, stop. Let's think about this. You can't let things stop you. You have to have the will to keep going. We've already talked about risk. We've talked about problem solving and the steps that go through that. Identifying problems, are lots of different techniques that you can do. Simulation like Monte Carlo, diagrams, interviews, cause and effect diagrams. These are all tools. And in terms of risk, you can line it up on what you think the probability, the magnitude, the impact, and how important it is to you. And you could set up your risk priorities of what you should be tackling. Remember, it's all about will.